we set that up as being needed if we want to do time travel. So go to the live before this one in order to get that full discussion. We thus have experimental evidence both that space-time can be warped from the bending of light during eclipses. So as far as like space-time being able to be warped, this we already knew. This is already known and experimentally confirmed, and that it can be curved in the way necessary to allow time travel from the Casimir effect. So this metal plate thing that we've been kind of discussing is the Casimir effect. If you want to look it up, it's Casimir. Casimir. So this Casimir effect actually allows for negative energy density, or the warping of time in a way that would allow for time travel. So this is all of this is to say that time travel in a sense could be possible. But how real is it? How practical is it? How attainable is it? And what kinds of issues one could have if we did this? And are we technologically, capable enough to allow for time travel? Those are the questions. But as far as physically being allowed, it may very well be allowed. Okay? One might hope, therefore, that as we advance in science and technology, we would eventually manage to build a time machine. So it's a matter of, as this kind of points out, it's a matter of technological advancement, whether we can do it or not. In the movies, it's already happening, but whether in reality we can do it or not, it would require sort of a fine-tuning of this metal plate stuff that we were talking about, right? And that may not be so easy. So, but if so, why hasn't anyone come back from the future and told us how to do it? So if it's difficult, why don't we have visitors from the future to tell us how to do it, etc.? There might be good reasons why it would be unwise to give us the secret of time travel at our present primitive state of development, but unless human nature changes radically, it is difficult to believe that some visitor from the future would not spill the beans. Of course, some people would claim that sightings of UFOs are evidence that we are being visited either by aliens or by people from the future. If the aliens were to get here in reasonable time, they would need faster than light travel. So the two possibilities may be equivalent. So this sort of like another reason why we think that alien visits would be kind of difficult is because they'd have to traverse very large distances to get here and may have to travel faster than the speed of light, which is, as far as we know, impossible. So that's another whole thing. However, I think Stephen Hawking thinks that any visit by aliens or people from the future would be much more obvious and probably much more unpleasant. If they're going to reveal themselves at all, why do so only to those who are not regarded as reliable witnesses? If they are trying to warn us of some great danger, they're not being very effective. So those types of things. Then he goes on to give a little bit more explanation of the alternative histories and things like that we talked about. I'll skip to the last part of this chapter, which is what we did not cover last night, so that the people who are watching and wanting to listen to the full thing can catch up with that. So the Feynman sum over histories. So this is something that we kind of mentioned in the book earlier, the Feynman sum over histories, where sort of these, for these various particle interactions, all of the histories that could possibly happen are kind of allowed. Whether that is something we can use to understand this whole situation better is something that he's considering here. So let me back up a little bit. The alternative histories hypothesis sounds rather like Richard Feynman's way of expressing quantum theory as a sum over histories. So Feynman had a way of expressing quantum theory as this sum over histories, like I mentioned, which was described in chapters 4 and 8. So in the same book, in the chapters 4 and 8, we kind of mentioned that. This said that the universe didn't just have a single history, rather it had every possible history, each with its own probability. So there might have been all kinds of different histories of the universe, but each with a different probability. Because remember, with quantum mechanics, we deal in probabilities. We don't deal in deterministic certainties of something had to happen in a certain way, and that's it. Like there is different probabilities of the different sort of outcomes that are associated with all those different trajectories and whatnot. So in Feynman's sum, each history comprises a complete space-time and everything in it, this space time may be so warped